Hello everyone. In last video, we were discussing about uniform motion. We will continue our discussion in this video. So, last video we have considered that the time and distance relation where distance was increasing with the time. Every time there is an additional distance covered by the fighter plane. Now let us consider one example where the distance is not increasing, distance is remaining constant with respect to time. Suppose in between the journey, somewhere in between the journey, I'm saying after the first second, the distance traveled by the object is 5 meters. Even in next second also, the distance traveled is 5 meters only. There is no change in distance. Even in third second also, the distance traveled is 5 meters only. There is no additional distance traveled. In fourth second also, it is 5 meters. So irrespective of time, whether it is first second, second second, third second, fourth second, the distance traveled remains the same, 5 meters only. Even in fifth second also it is the same. Now, as I said, distance remains constant with the time for this journey. Now, if I plot the distance versus time graph, what I will observe is, now again, just for understanding, we will divide the time interval into four parts, one, two, three, four parts. And for four parts or four particular time intervals, if I observe the distance covered and if I plot the lines for this journey, see, for the first time duration or first time interval, how much is the distance traveled? This much is the distance traveled of 5 meters. Now, in the second time interval, how much is the distance traveled? This much is distance traveled. In the third time interval, this much distance traveled. In fourth time interval, this much distance traveled. So, irrespective of the time interval 1, 2, 3, 4, the distance covered by that object it remains the same. There is no any increase or there is no any decrease in the distance traveled by the object. Distance remains the same. Somewhere here is the first second distance traveled is 5 meters, second second 5 meters, third second 5 meters, fourth second 5 meters, fifth second 5 meters. So this distance is constant throughout the journey, or even though time is increasing or time is progressing, distance traveled by the object is constant. So this kind of motion also we will say as a uniform motion. In this case, we have said that velocity is constant. Velocity here is constant because the ratio of ds divided by dt if I take, or the slope of this line if I take, it is constant. Here velocity is constant. But in this case, velocity is zero. Irrespective of the time duration, velocity, magnitude of the velocity, it is zero. About this graph, we will discuss more in distance time graph and velocity time graph. There, the more clarity of this graph we will get it. But just now for understanding, we will say, just for time sake, we will say that the distance versus time for these values, if I plot time versus corresponding distance, the value of the distance or magnitude of the distance corresponding to these time intervals, any time interval, the distance covered by the object remains the same. So this kind of motion is also uniform motion, and this kind of motion where the equal distance got covered in equal interval of time. So this is also an example of uniform motion, and this is also an example of uniform motion. We will discuss more about this uniform motion in coming videos. Thank you.